Hi and welcome to Duality Repair. I have another Rotel unit. This is the RSX-1067 surround sound receiver, and it's in good shape cosmetically, but it's got several problems that we'll have to deal with. But before we start the troubleshooting and repair, I did want to bring up that I just recently started a Patreon account, and I did this because I want to be able to work on more equipment like this. I love working on these amps, these receivers, but of course I'm buying this with my own money, and so I'm buying it and then fixing it and selling it, hopefully. But I'd love to be able to work on it more often, as well as higher end units. And the only way I'm going to be able to do that is with some sort of outside funding. So if you're one of those people that wants to see more content from me, or wants to see me working on higher end equipment, whether it's amplifiers, receivers, oscilloscopes, power supplies, please consider joining me on Patreon. The link will be in the About tab. One good benefit about joining me on Patreon is that if I were able to receive enough support, I'd be able to give some or most or even all of this equipment away. I have no use personally for this equipment, for most of it. I keep a few oscilloscopes and power supplies that I work on, but a majority, especially for this audio equipment, I have no use for it. I have my own setup. I don't need it. I simply like working on it. And so if you're interested in seeing more content from me working on higher end equipment, or just interested in possibly receiving free equipment, please consider joining me on Patreon. All right, that's enough of that. So let's get into the failures. So you can see we do have standby light. That's great. Let's turn it on. And the initial problem shows up immediately right here. So the volume doesn't change at all. Okay, we got a little bit there, but it should be changing rapidly right here. The other problem I haven't tested because of this volume issue, as advertised, is that one of the outputs is out, and so there's obviously several surround outputs. I believe they said one of the center outputs is out. We'll have to test that, but we have to fix this issue first. And so normally I don't jump into the schematics right away, but I did on this unit. And so if we look at the schematic, we can see that the volume knob as well as the bass and treble control knobs all controlled by this one microcontroller IC1. And so if we go back to the unit, we can see that they label this LF for low frequency. That's the bass control. The bass control works just fine. We can go from min to max, no problem. Same with the high frequency or the treble control, no problem there. So that tells me that that IC1 is probably functional. And so there's probably something wrong with the circuitry leading to the volume knob or the volume knob itself. And so one thing I did find out just before I started this video is that, yes, I cannot adjust the volume by just turning it standard, but I had some flashbacks from my Harman Kardon where the volume knob was definitely smashed in and it broke part of the input board there, or the front board. And so I thought something like that may have happened here. This is protruding further than anything, even further than these LF and HF knobs. And so I thought maybe somebody pushed on it a little too hard. And so what I tried was I pushed in a bit and tried turning. And if I get the pressure just right, you can see it turning, it turns a lot easier. And so you can see I can adjust that volume halfway decently if I apply a little pressure. And so that tells me it's probably some sort of physical or mechanical issue with this volume knob, or how it's attached to the board. I don't really like that. I really hope it's not like the Harman Kardon back in the day where the board was cracked in several different places. That thing was just toast. I really hope it's some sort of weak solder connection or something like that. But the only way to figure it out, obviously, is to get inside. So let's do that. I removed the front faceplate here, and it's very, very straightforward. We have 4 screws on the top here. We have several screws on either side. You can see the screw holes here. It's the same all on the other side. And we also have several on the bottom. All those had to be removed. I would only have one tip if somebody's trying to do this. This front left screw right here is not accessible due to the heatsink on this board here. So what I did was I removed 3 or 4 screws. I was able to slide the board over enough so that I can get my screwdriver in there and remove the screw. Now, I still don't have access to the board I need, so I need to disassemble this even further. All right, we're in pretty deep now, as you can see. I have the board removed from that front panel, and there's only a little bit further that I can go, removing this board from this mounting block here. Unfortunately, I'm not going to be able to do that right now. This, I believe this is the bass control knob, is, I believe it's glued on to the shaft of the rotary encoder. I cannot get it off. This one comes off pretty easily, but this knob does not come off. I think I'll break it if I try to force it, so I'm going to leave it on for now. I don't think I need to take this off for now. I looked around the board, so obviously here's our volume encoder, and that's these 3 pins here. And I believe these 2 pins are for mounting to the board as well, but these 3 pins are the actual contact pins. And I looked around quite a bit. I don't see any signs of the board being cracked. I think the solder joints look good. The IC1 over here looks okay. You can see a lot of flux residue over there, but that's fine. I'll probably clean that up before I get this reinstalled. So I'm thinking that it's actually this rotary encoder that's gone bad. So we can test it before pulling it out of the unit. I'm going to need to solder some wires to these 3 pins here because I cannot get my leads on there. I want to be able to clip them on there and have a free hand to rotate this. So I'm going to solder some leads on here and we'll test it. I'm ready to test the functionality of the volume encoder. You can see I have both the volume encoder knob as well as the treble controller knob marked, so that'll be really easy for us to tell how far we've rotated it when we're testing. I'm going to use the treble control encoder as a reference because it's functioning really well, and you'll see that in just a minute. Very quickly on the theory of these types of encoders. They're very, very similar, first of all. They're both 24 pulses, which means that as you rotate each of these encoders 1 full revolution, you'll short out pin 1 to pin 3 24 times. You'll also short out pin 2 to pin 3 24 times. The only difference is that these 2 pins are going to short out of phase due to the way that they're located inside the encoders themselves. And that's how the IC knows what direction you're rotating the knob. It's looking for which pin shorts out relative to the other. And so if pin 1 shorts out to pin 3 before pin 2 does, it knows you're rotating in a certain direction and it turns the volume or treble or bass up or down accordingly. And so the setup I have is I have my negative lead of my multimeter hooked up to the ground pin or the common pin, and it's all the same between all 3 encoders, which is pin 3. And I'm going to start by having the positive lead of my multimeter hooked up to pin 1 of the treble controller. Again, just as a reference, you can see how well it's functioning. You can see what an encoder should look like. And so I'm going to start with this. Now again, as I rotate this, if I were to rotate this 1 full revolution, we should hear this pin short out 24 times. And I'm not going to do a full revolution. That's overkill. I'm really only going to do it, I'll do it a half revolution just to show my point. So I'm at 6 o'clock right now. I'm going to rotate it to 12 o'clock, simulating about a half a revolution. We should hear about 12 shorts to ground. So let's do that now. So that's a half a revolution. You can see it's now at 12 o'clock, and I don't know if you counted, but it was exactly 12 counts. So this is a perfect example of what an encoder should function like. I'll now switch the multimeter pin, my lead, to pin 1 of the volume encoder, and we can test that. All right, so we're hooked up there now. Again, I'm at 6 o'clock. And obviously this is a larger knob, but still, again, it's 24 pulses. So as I rotate it a half a revolution, again, I should count 12 discrete steps. So watch what happens as I rotate this. So hopefully you can tell that it's not seeming very normal right now. It's not acting at all like the treble control was. I've only turned it about a quarter of a revolution, and it seems to be shorting out and going open intermittently. And so I'll continue on just to the half revolution point. I'm going very, very slow, obviously. So that's about a half a revolution right there, and you can tell it was really didn't sound anything like the treble control. So I'm still very, very suspicious of the volume encoder. And so at this point, I'm going to try and remove it from the board, and so we can inspect it. It's possible that we can open it and clean it. If there's something physically broken inside, it'll probably be a lost cause, and we'll have to try and find a new one. But let me get this off the board and we can inspect. Here's the volume encoder removed from the unit. It's always a good idea before you replace or tear something apart to test it outside of circuit. I just did that, and it tested exactly the same as in circuit. It's not even worth showing because it tested identically. And so I'm still very confident that there's something wrong with this. I've never taken one of these apart before, but it looks fairly straightforward. It looks like there are 4 pins, 2 on either side. Sorry about that focus. And once I remove those, this green package should separate from the metal package, and we should be able to see what's inside. Alright, I removed all 4 tabs from this cover, and I removed it from the encoder. And to my surprise, this looks to be physically intact, which is great. I think we're going to be able to get this running again. Now that it's exposed, we can check out the operation of it a little bit more closely. Again, we have pin 1, pin 2, and pin 3. Pin 3 over here, that was the common between all 3 encoders. That makes contact with the center of this disc at all times. You can see as I rotate the disc, it makes contact at all times. While pin 1 and pin 2 come in over here on the left. And the way they're able to make contact or short to pin 3 out of phase is that they're very slightly different lengths. And so you can see the pin closer to the bottom is slightly longer than the pin closer to the top. And so that, if I were to rotate, say, counterclockwise, makes contact with one of those 24 contacts jutting out from the center of the disc just a little bit before the top contact there. And vice versa if I rotate it clockwise. So this is great. It looks to be operating correctly. I think there are one of two possibilities that's causing our issue. Number one is that 1, 2, or all 3 of the contacts that's pushed against the disc has lost its tension, and it's not making enough electrical contact with the disc. And so that would be a pretty simple fix. I can remove this green section of the encoder here, which houses the contacts, and I could push them out just a tiny bit so they make better contact with the disc. However, these are really small, really fragile contacts, and I only have one of these, so if I break one or bend one out of shape too far, I'm out of luck. So I want to attempt to fix it using option 1, or the other option first. And so what I think the problem actually is there's just too much grease built up on all 3 of these pins, especially where they make contact with the disc. And so it's kind of difficult to see from this angle. I'll remove this green section of the encoder, and again, this houses the contacts. So here's the disc by itself. It's hard to pick up on camera, but there is quite a bit of grease on there. Now we do need grease. We can't have straight metal to metal. While you're rotating this, you're just going to build up too much friction, and you're going to wear the metal down. So you do need some grease, but I think the problem is that the grease has built up too much on these contacts, and it's difficult to see, but there's a lot of buildup on there. You can see it built up on the actual green piece here. But so what I will do is I'll carefully clean all of the excess grease off of these pins. I'll also remove just a little bit of the grease from the disc itself. Not all of it again, we do need some of it. I'll put it back together and we'll test. We'll see if that makes a difference. If not, I will attempt to bend these pins just a little bit to give them a little more tension against the disc. I removed the excess grease from the disc as well as the 3 pins, and I've also pushed all 3 pins out just so they make as much contact with the disc as possible. But still the encoder was not functioning as it should. And so I removed it from the unit, and I've replaced it with the encoder that was previously in the high frequency or treble control position. So that's currently in here now, and as you can see, it's working just perfectly. So this encoder was definitely the issue, and so I'm going to scrap that. I actually like the way this detented style encoder feels, so I'm going to leave this in its place. And I've just ordered a replacement for it. I've ordered several actually, and I'll replace it once it comes in the treble control position. And so while we're waiting, we can troubleshoot any remaining issues that we have. So I've identified the next problem we need to tackle. I'll turn the unit on and watch what happens as I measure the AC voltage on one of these speaker terminals. So we're at about 1.3 volts AC, And I can decrease that by turning the volume down. And it does fall to a tolerable level of less than 5 millivolts. But still, when we power that unit on, we have a lot of AC voltage out of the speaker terminal, so that's going to produce simply humming in your speakers. And I've checked all of the outputs. It's just one of these center backs that doesn't have the AC, and I think that one's actually just dead. So we're going to have at least one more problem to resolve. Let's take a look at the schematic next and see where we might want to start probing. Since we have a common failure across all of the outputs, we want to look for a common source. And the most likely common source of AC voltage is from the power supply section. So I'll probe all of these DC outputs from the power supply section. I've already checked the power board, and all of these outputs are very easily accessible. So we'll probe each individual one until we come across one with AC voltage. Alright, so I believe I found our AC voltage source. This is the analog 5-volt pin. And as you can see, we have about 800 millivolts of AC, and that's a 5-volt rail. So even if we look at the DC voltage, we can see that's pretty low as well, 4.4 volts DC. This is regulated by a 7805 5-volt regulator, and these are usually very, very accurate within a few 100ths of the set point of 5 volts. So it should be no worse than maybe 4.98 volts and no greater than 5.02 volts. So this is way off in DC, and it's our AC source as well. So the 7805 that regulates this 5-volt analog voltage is right here. This is IC1053, and we know the input, or we know the output is about 800 millivolts of AC. Let's take a look at the input. You can see we have 2.35 volts of AC voltage on the input. That is much too high. We cannot expect that regulator to be able to handle that kind of AC voltage. And so this is our problem. Now, since the regulator has an input AC voltage, we know that there's something going wrong before the regulator. And there's only one thing really that can go wrong before that, and that's the smoothing capacitor C1080, which is right behind the heatsink here. And physically it looks okay, but my suspicion is that it's going or gone bad. And so AC voltage on this analog 5-volt rail makes sense for the failure we're seeing. The analog 5-volt feeds the DACs. And so if we feed an AC voltage into a DAC on the analog side, we're going to get AC voltage out. And so that's what's giving us our AC voltage. So I'm going to replace C1080. One thing I did while I was checking for a baseline, I looked at all the other 7805 or the 5-volt regulators. I looked at their inputs and outputs. There's two over here on the left, hidden behind the multimeter. They had virtually zero AC input and output, about 1 or 2 millivolts each. This one right here, this is the digital 5-volt. You can see the output, if I can get my probe on there, the output AC voltage is only 1 millivolt, but it does, however, have a bit of AC on the input, 115 millivolts. So although the regulator can handle that, I think that's a sign that that smoothing capacitor has gone bad as well, or is going bad, C1088, and we might as well replace that as well. So I'm going to remove this power board. I'll remove the two capacitors in question. We'll inspect them, we'll check the ESR, and regardless, I'm going to replace them. Before we fix this AC issue, I want to show you what sort of impact this 1.5 AC volts has on the speaker. So I'm going to turn it on. I have no input, but I have one of the speakers connected, and you can see what it sounds like. Yeah, it's a terrifying noise. So we need to get rid of that. I believe removing and replacing C1080 will do that. All right, I have C1080 and its replacement here on the left, and C1088 and its replacement on the right. The C1080 or 4700 microfarad at 16 volt replacement is a little bit bigger. It's quite a bit bigger. The replacement I had isn't exact. It's 4700 microfarad at 35 volts versus 16, so that'll work just fine. And the spec for that is no greater than 0.05 ohms, and you can see we're well in spec at 0.02 ohms. So now we can see how bad C1080 was, that it was giving us 2 volts of AC, 11 ohms ESR, absolutely terrible. Definitely needed to be replaced. Let's take a look at C1088. This is the replacement. It's an exact replacement, 10,000 microfarad at 16 volts. The spec is no greater than 0.03 ohms. We're well in there at 0.02. And again, I didn't think this one had completely failed, but it was on its way out, as we did have some AC voltage on the input of that 5-volt regulator, and indeed we're at about 0.9 ohms, so that one is failing spec as well. So both of these need to be replaced. I'll replace them now. I'll reinstall the board and we'll verify that our AC issue on the outputs is gone. I replaced C1080 and C1088. I also replaced the high frequency or treble control encoder. Since I have everything back together, I must be pretty confident that it's going to work. So let's turn it on and see if we have any more AC on the output. No AC. Let's make sure the treble control knob still works. It does. Now let's do a sound test. Sounds pretty good. This one is done. I appreciate you watching. Again, please consider joining me on Patreon if you'd like to see more videos like this. And we'll see you next time.